Alright guys, so we are starting 3.5, which is our last lesson of chapter 3. Now, I told you there's not anything necessarily new in this lesson. However, in the past, what we've been doing the past couple weeks, we've been saying if two lines are parallel, then their angles have certain relationships. So that's what we've been doing the past couple of days. If two lines are parallel and they have a transversal, then the angles have certain relationships. However, now this whole lesson is finding the converse. So you're just doing the converse. Do you remember that word? Which is not P then Q, but it is Q then P. So all we're doing is saying, well, if our angles have certain relationships, then it proves that they are parallel. You kind of see what I mean? So we're not looking and assuming that they're parallel anymore. We're looking at their relationships and determining if they are parallel. Yes? Yeah. Can everybody see? There's plenty of seats up here if you need to move. It's okay, Alex. Alright, so we have a couple of fancy theorem names. However, I'm not going to always make you write these fancy names. Okay? Because converse of corresponding angles postulate. That's just a lot to write. So all this is saying is that if 1 is congruent to 3, or 2 is congruent to 4, or 5 is congruent to 7, or, I'm going to use a triangle, 6 is congruent to 8. If any of those are true, then we know that A is parallel to B. So that is the main word here, corresponding. All I'm going to make you write when we have to write these is like corresponding postulate or theorem, as long as you say corresponding. Okay, so the next four are not as if they're not. This looks like a lot of words. Don't freak out. If you have alternate exterior angles, so for example, if angle 1 is congruent to 3, then you can say P is parallel to Q. So it's the same relationship we've been working with the whole time. We're just working backwards. If 4 plus 5 equal what? 180. Then P is parallel to Q. Consecutive. If angle 6 is congruent to angle 8, then P is parallel to Q because of alternate interior. Okay, this is the only one that's kind of different. If you have two lines that are perpendicular to the same line, aka if you see two squares, that mean they're 90 degrees. If both of these are 90 and R is perpendicular, then P is parallel to Q. So because P is perpendicular to R and that Q is perpendicular to the same R, because both of these are perpendicular to the same line, then we can say P is parallel to Q. Alright, so that's it. We just have to practice. Okay, so on the back, you have to tell if these lines are parallel. But we're not really using numbers. So if they're saying, assume this is correct. Assume angle 2 is congruent to angle 8. So here's 2, and here's 8. Well, what theorem could we use for 2 and 8? Okay, so write alternate interior. Now, to me, this is the tricky part. We have to determine, does that make A parallel to B, or does that make L parallel to M? What do you think?
Maybe
A to B. Yeah, because here's your transversal. So if you cut M out, can you still assume A is parallel to B?
Yeah.
That's what I would do. So cut out whatever is not used. If you can still say that's true, then it's the other two lines. So you would just write, by alternate interior, A is parallel to B. Okay, angle 3 is congruent to 11. 3, 11. Well, what relationship is that? Corresponding. So both of those are on the same A. So they're on line A, but technically they're on L and M, and A is the what? Transversal. So 3 and 11 being congruent determines that L and M are parallel. What about 12 and 14? Yep, alternate exterior. (12) and 14 are on transversal M, but that determines that what is parallel? A and B. A is parallel to B. Okay, now we might be able to solve this if we were given numbers, but next it's talking about 1 and 15. So without any numbers, I don't know anything that tells me 1 is congruent to 15. Now, we could probably say, well, corresponding, vertical, but I don't know that 9 and 13 are the same. So there are going to be scenarios like this. It's not a relationship that you know, and it's not possible to tell if they're parallel. They might be, but it's not possible with what we're given. So you can't determine what lines are parallel based on angle 1 being congruent to 15. Bless you. All right, 8 and 13 equaling 180. Yes, that's true. We can determine that based on what relationship? Consecutive. Now, if I cover A, is that statement still true? Bless you. Yes. So B is the transversal, but this statement is determining that what two lines are parallel? L and M. Okay, same thing. However, it's a little, this T is just messing us all up. Transversal T just throws a wrench in there. So, here is what, you can either have R's parallel to S, that's one option, or you can have what? U's parallel to V. Those are the only two options. Okay, so try 6 and 7 on your own. Check your answers with mine. And then keep trying. Go ahead and finish 310, and then just look up and check mine when you're done. Here's the thing with 9. If I know for sure U is parallel to V, right? Then I can say, well, 3 is congruent to 9 and 9 is congruent to 7. If I know they're parallel. But now I don't know they're parallel and I'm having to prove that they are. So just stating that 3 is congruent to 7 does not determine it. Because do you know a relationship that looks like this off the bat? No. So if you see one of these that's not, like, straight off the bat, you do not recognize it, then it's probably not possible. Okay? Yes, ma'am.
I understand how, like, on 5 and 8, like, when you guys are like,
How I went over what's parallel? Is that what you're asking?
how did you get, like, I got that all.
Okay, so 3 and 6, their relationship is consecutive, which means if angle 3 plus angle 6 equals 180, then U is parallel to V. You know to use U and V because those angles are on those two lines. Now for number 5, if 8, if the measure of angle 8 plus the measure of angle 13 equal 180, then you know that the lines those two angles are on, which is L and M, are parallel. Okay? All right, so these 6, they basically look the same thing we've been doing, and they basically are. However, you have to make sure that X can be solved. That's the whole point. So, I'm sorry I didn't leave you very much space, but I figured you could just work all of it down here. So, if we're doing number 1, what relationship are these two? Because you have to state it. Look, identify the postulate or theorem. So, what? Exterior. Good. You can just write Alt X. So, are they equal to 180 or equal to each other?
Equal to each other.
Okay, so I'm going to set them equal. 5x minus 5 equals 6x minus 20. Is that what y'all got? Okay, well, if I can solve for x, and you can plug it back in and try it if you want to, but if you solve for x, then L and M are parallel. So that's all I was looking for. What was x? What was the theorem?
I think I messed up somewhere.
Okay, I subtracted 5 over, so 6 minus 5 was x, and then negative 5, I added 20. Negative 5 plus 20 was 15. Listen.
Do you not write L as parallel?
You can, if you want to. Okay, so number 2, what's the relationship? Alternate interior, which means if L is parallel to M, then these equal each other. So 4x plus 20 equals 6x. I would subtract 4, which would leave me with 2. And then you have 20. Basically the same. However, on your test, if it tells you to identify the postulate, then you need to. If it just says solve for x, then don't worry about it.
So then what does that mean?
Huh?
Like, L to M? Are we writing them?
You can, but if you find x, then L is perpendicular to M. Or parallel, sorry. Okay, well 3, what's the relationship? Alternate interior. You could also say that if that's 90, then this is 90, and then supplementary or right angle. There's a little leeway with that one. So then these two have to equal each other, which means 3x equals 25, and x is equal to 25. Yes? No? Maybe so? Okay, for now, 4, 5, and 6 is your homework. Okay? That's it. And you might even have time in just a minute. But I want to skip to the back, because look what's on the back. Oh no, they're back. but they're painless. They're like a sugar ant compared to a fire ant. Okay, promise. So, we're actually not going to do proof 3 and 4 for now. Don't mark it out, but just know that I'm going to stop here. And the reason I'm stopping here is because there's only one of these proofs on your test. So we can do 3 and 4 tomorrow or even Thursday, but we're going to skip it for today. So, here we go. 15 is congruent to 5. Yeah, so here's this one's a little different because given, they put it all the way down here. So I wouldn't actually write given right here. Now, if you were doing this from scratch, you could and it would be fine. However, if they put given down here, I'm going to write everything that's given right here. So angle 1 is congruent to angle 5, and angle 15 is congruent to angle 5. Okay, so now we want to prove, and if we're proving this, don't you think that's going to be in the last one? So L is parallel to M, and R is parallel to S. Okay, now let's talk about how we know this. Yes, we're given, but if we looked over here, angle 15 being congruent to 5 is what theorem? Okay. Well, what about 13 being congruent to 5? Vertical. Well, then how can I say 5 is congruent to 13? Think, huh? Not course? Let me look. Okay, yes, but look, without using that, look here. If 15 is congruent to 5 and 13 is congruent to 15, how can I cut something out to just say 5 is congruent to 13? Transitive. Now, I see where y'all are getting throwback. Transitive. I see where y'all are saying corresponding as well. I prefer transitive because you're cutting these out, you're cutting the 15 out, and you're saying, well, then 5 is congruent to 13. So then, if 5 is congruent to 13, and by the corresponding theorem, we can say R is parallel to S. And here, you had to prove that L is parallel to M and R is parallel to S. So L is parallel to M, we used 15, not 15 and 5, not 13 and 15. But that's why we had to figure out 13 and 5. No.
1 and 5.
1 and 5, yeah, there you go, 1 and 5. But we were given that, so that's how we knew L is parallel to M. However, to prove that R is parallel to S, we had to show 13 and 5. Okay, let's try the next one. So on your test, the theorem that's there is literally you just have to show, well, this is congruent to this by this theorem. Therefore, they are parallel. Yeah, but it's not long. Okay, so here we go. They're starting with what's given. So for A, I'm going to go ahead and write what's given. Angle 1 is supplementary to angle 2. Then they give us angle 2 and angle 3 form a linear pair. Well, we know that because of the definition of linear pair. If they're 180, then they are, wait, 2 and 3. Oh, because right here, that's how we knew that. 2 and 3. 2 and 3 form a linear pair, definition of linear pair. Okay, so look at what we're trying to get to. We're trying to get that angle 1 is congruent to 3. So we know 1 and 2 are supplementary, or that's what we were given, but you could also say consecutive. We know 2 and 3 form a linear pair. Do we know anything about 2 and 3 being supplementary? Yeah, if they're a linear pair, then they can be. So 2 and 3 are supplementary because they're a linear pair. You could have, if you were writing this one on your own, I would have been okay with you skipping B, because 2 and 3, you can look at that and know that by the supplement theorem that they're supplementary. Okay, well, if 1 and 2 are supplementary and 2 and 3 are supplementary, then transitive 1 is congruent to 3. Remember that time we used that if the angle is, what was it? What did we use? Complementary to the same angle, then those two are complementary to each other, or congruent. Do you remember that? It was like 1, and we had to go over, and it was like if angle 1 is complementary to angle 3, and angle 3 is complementary to angle 4, then angle 4 is congruent to angle 1. That's kind of what just happened. So if 1 and 2 are supplementary and 2 and 3 are supplementary, then by the, what did we call that? Congruent sup theorem. 1's congruent to 3.
Yeah, you just said transitive.
Or transitive, yeah. Then 1's congruent to 3. Okay. Well, 1 and 3 being congruent is what relationship? Okay, so by corresponding, L is congruent to P. I mean M, sorry. Alright, in the next few minutes, here is your task. You need to finish 4 through 6. You need to finish your ladder thing and turn that in. You need to finish your transversal packet and your rough draft. Now, your rough draft isn't for points. It's just to help you. So if you don't turn that in, that's on you. Okay? Transversal packet is due tomorrow. 4 through 6 you need to do just because you need to do it. And then your ladder, if you need to push this back to being due Thursday, I'll be okay with that. Okay? If you've already done it, good for you. You don't have to worry about it. Is everybody clear on what we have to do?
Yes.
Okay.
Can I ask you a question on mine real fast?